Given a stream of tweets, build a system that classifies which ones are toxic. Thank you so much for being here with us today, Jay. Can you quickly introduce yourself for our viewers?
Hey, thank you, Angie. Thanks for having me. I'm Jay. I am a machine learning engineer. I'm quite like 4 years from now. I work at a company, Delivery Hero, which is based in Berlin, Germany. That's pretty much it.
Okay, cool. So I'm really interested to hear your take on our problem today. So our question today is, given a stream of tweets, build a system that classifies which ones are toxic.
I see. Uh, so you said tweets. So these are text informations, I
Yes, it's all
assume.
text.
Okay. So do I have the data set which I can already look at, and also what does the data set look like in terms of labels? Does it have labels or does it not have any labels?
Yeah, so we can look at the dataset. It's loaded into this Colab here. And essentially, the dataset is all text. You don't have to worry about any multimedia, and the targets will be binary labels of whether or not it's considered harmful or toxic.
I see. So it's a table, rows and columns with the text column and then a target column, which is basically binary. I
Yep,
see. So it's a supervised kind of a task. And also,
exactly.
I say it's when you say harmfulness, right? You're basically trying to classify it. So it's a classification problem.
Yes.
Um, okay. So how also you said there are two labels, binary labels.
Yep.
Are there more to it?
No, it's just the two labels.
I see. It's a binary classification problem then. Okay. So so how often do you want these predictions to happen or these harmful text classifier to operate on? Just to get me an idea about whether I want to build a live model or a batch model kind of a thing.
I think for now we can start off with a batch model, and then later on, if we have the time, we can get into what how you might modify it to be live.
Are there any downstream services which will be listening to these predictions? Are we going to model something out of it? Like if there is an harmful text, are we doing something, or which will help me to understand what kind of data models I would need, both for the input wise and output wise?
Yeah, so for now, maybe let's assume that the company is going to use those to like filter tweets or like filter what shows up on your newsfeed. But for the
Uh-huh.
most part, we don't have to worry too much about what's downstream. You mostly just need to focus on like the model itself.
I see. Okay. One final question about understanding this problem. Does there is a model already in production where a company already has this thing? So I'm building a new one. So should I have to worry about A/B testing, business metrics, and all this stuff?
Um, yeah, so we can say that there's no model in production yet,
I
but
see.
because it's going to go into production, it would be helpful for us to talk a little bit about like A/B testing, how you would deploy
Hmm.
it, and how you would monitor it during deployment.
Great, great. Uh, would we have one model across region, like per geography basis, or like US, APAC, and LATAM kind of a thing?
I think we can start out with just one model overall, and then later on,
Hmm.
maybe we can talk a little bit about how that might be adapted towards different regions.
I see. Uh, yeah. Before I get started, I would like to have a look at the data set so that we can start talking about it. What do you think?
Yeah, I think it's a good idea.
Okay. Uh, so I have this collab. I'll quickly get stuff into pandas. I would also need numpy for like something can come up. Uh, right. So I'm gonna get my data into this thing since it's a CSV file, right? CSV.
Hmm.
And then I'm gonna say tweets underscore flat underscore v2.csv. Looks like the data is here.
Yeah.
Data underscore df dot head. Just to look what the data set looks like. Um, I see. So there is. an unnamed column here.
Hmm.
I suppose it's kind of an
Yeah.
index copy of it.
Yes.
Um, so there is an harmful column, which is basically a target column, and there is this tweet set. Let's see. Um, okay. So I would design a text classifier to basically read these text and
Hmm.
then say whether harmful or not, a binary
Hmm.
text classifier.
Okay.
Uh, I would probably sketch out the thought process that I have right now, and then we can look into the full code structure. What do you think?
Okay. Yeah, I like that. Hmm.
Right. So it's a binary text classification problem, basically, right? Basically, in the area of text, right? Um, so I'm gonna have a pre-process pipeline, right, which will basically help me to modify the text, convert that to text to a number format so that the machine learning algorithms over underneath can understand. I
Okay.
then want to have a training setup ready. Probably I'm going to use TensorFlow to do these things. I will
Hmm.
also have an evaluation on the test data, basically, and
Hmm.
to see how well is my classifier working on.
Okay.
Correct.
Okay.
Yeah, even before that, I would probably have a look at the data set in terms of number of samples, composition, I would say number of samples and value counts, which basically says number of harmful versus not harmful samples. It gives me an idea about whether the data set is balanced or unbalanced and all this stuff.
Okay. Yeah, it's
All
an
right.
important consideration.
Yeah, thanks. So let's get started. Let's look at the first step. So basically, I want to look at um, data underscore df. Let's say, I could say shape current. Yeah, so there are around 56,000 samples and three indexes, three columns. I guess one of the column
Hmm.
can be dropped. You can easily drop one of them. But before this, data underscore df dot drop. Let's say this guy, so that we have some sort of a clean data set.
Gotcha. Okay.
Okay, I need to keep this guy. Yeah, so that's gone. The unwanted column
Hmm.
is gone. That's good. So you
Okay.
have the number of samples at this one, and then I also want to look at this value counts, which is basically on the target column, which is our harmful column,
Hmm.
to get okay, to get an idea about the unbalancing. Okay, there are
Uh-huh.
around 32,000 of not harmful samples, I guess, and then harmful one is basically 24,000. I
Hmm.
guess there is a difference of around 30% um, in terms of the number of in terms of balancing, right? I think that's okay. We can also cut them down to make it balanced, but let's anyways go ahead and build the pipeline and see how the classifier performs, and then we can think about tuning the data or the models. What do you think?
Okay. Sure. And by pipeline, do you just mean like the data preprocessing?
Yes, yes, exactly,
Okay.
exactly.
Yeah. So tell me about
Um,
that.
Sure. I would want to also look into the sorry about the bit. This one. So basically, I want to look at the data,
Hmm.
some random samples of the data. Correct.
Hmm.
Random index. basically what I'm trying to do is I want to randomly look at, shuffle the data and look at the tweets completely so that I get the sense of the words present in the various cases, correct? So that I know what kind of data that I should probably test. Um, So I have this one data which says low key has no use. My life is as an L. Attack, bull, game, empty, city side, car accident, flocking towards, yeah, is kind of harmful text here. Okay. So there are some negative words in the text. So it's good enough for us to understand, okay, our data is kind of good to see if things are working. So let's make the pre-process pipeline. What essentially I want to do is I basically want to convert this text into a sequence of numbers,
Okay.
and then pass it to my machine learning algorithm, which I write. Essentially, to do this, I could write my own pre-processing pipeline, which basically can use NLTK modules like NLTK, which can do stripping of punctuations, stop words, lemmatization, standardization, all this stuff, and stuff on the text, and create a vocabulary out of it using TF-IDF or back and forth kind of a thing. But even the popular choices are from basically from Hugging Face. I'm assuming that you're familiar with this Hugging Face thing.
Yes. Yeah.
Um, so I'm going to use one of their transformers to basically make this whole process with a single one, with a single module that they have. Uh, so I'm going to pick up this BERT tokenizer. It's kind of a popular one and also uses something like what do you call subword tokenization, which basically
Yeah.
will capture the words like you have capture the words just based upon their frequencies plus their usage, and words
Right.
like annoyingly can be saved both in the vocabulary, right? Annoying and
Yeah.
ly.
Okay.
Okay, it works better on the new words basically, right? They sorry out of vocabulary words. Okay, and
Are you
then yeah,
saying by that, do you just mean because like new words, they might still be built out of sub pieces that you've
correct,
seen already? Yeah.
correct. So I mean this is kind of a transfer learning, right? I'm actually leveraging the uh, pre-trained models, which basically trained on all the English words, and then I'm trying to apply this to my data set, which is completely in English, maybe in different format or all these things.
Uh huh.
Correct.
Okay.
I'm going to use BERT paste there because this cached thing actually works both for capital and small letters. So we can build an vocabulary based on that, and also they do a lower casing and then apply all this stuff, which is good.
Right. Okay.
Uh,
I
okay, what you
think
said, but
it's supposed to be base without the
base,
D. Yeah.
base and cached. Yeah, thanks.
Yeah.
Okay, it's getting so the Hugging Face actually allows us to get access to this, which is good. Um, so what I'm trying to do is I'm gonna get all my sequences in X variable, right? Uh, X and Y are kind of legacy variables to keep using in new code. I'm going to put the target column, which is harmful. and then say values. I'll also say values here. So I get the ND NumPy based arrays of both these things.
Okay.
And then I'm going to basically have model inputs, which basically takes my tokenizer. So the first step is tokenization, right? Tokenizer, and then I'm going to pass a bunch of sequences. So even before that, I have to make some sequences, which basically use some list comprehension to do it. Sequence and x dot values. Oh, I am already in values. And then you want to say sequence. So you have list of lists basically. So that's how the tokenization accepts. I'm gonna give sequences here, and then I say padding. Basically says you have different length of text, and then you want all of those texts to have same length, so that we have
Okay.
a square matrix.
Uh-huh.
Well, not a full matrix.
Yeah.
Yeah, and then I also wanna, since I'm working with tensors, I'm gonna use return tensor. I think I forgot about this. Yeah, I see. Yeah, return tensors. TF. Yeah, this looks good. This basically gives me a tensor of model inputs. Um,
I think it might be return tensors plural.
tensors plural. Okay.
I think.
Let me stop this. Yeah, that's why it says written tensor is not recognized. Good.
Yeah.
Okay. I think the runtime got restarted. Um, Give me a second. I'm gonna get it. Okay, restarting, running again. Just good. Just running. Looks like it's taking a bit. Guess because we got around 56,000 samples.
Yeah, it's a
Maybe
lot.
we could, yeah, maybe we could use a GPU on top of it to make it more faster. But I guess since we anyway started, we wait for it a couple of seconds more. Okay,
Okay.
that's
Great.
good. So we have the model inputs, which is basically, this is a format given by the tokenizer, which you have input IDs, you got token type IDs, and attention masks, I guess. Yeah, attention masks. Which are kind of useful for any other model like BERT to consume in and use it. But I'm going to use input IDs, which is basically the tokenized form of your sentence,
Yeah.
and
Okay.
pass it to my data sets and all these things. Okay, I'm going to use TensorFlow from now. TensorFlow STF. So I'm going to prepare my data set, right? I'm going to use tf-data.dataset API um, to actually load the dataset into my tensor format. So because I want to build up a sequential model based on TensorFlow, so that I want to push all this information there.
Gotcha. Okay.
Okay. Then you're gonna pass your y vector, which is target label, and also model underscore enforced, which is basically your vectorized form. We're going to pass only the input IDs. I think that's what they are called. Um, yeah. And then, okay, so we could do this. The nice thing about this data set is you can actually do a bunch of stuff. For example, you can, for like you can get everything on the memory, not all the things on the memory, but some of them, like shuffle, randomly shuffle the data set, and get prefetch the data set, kind of a things you can do. It's mainly for performance. Since we have
Right. Yeah.
56,000 samples, I'll try to do some fancy stuff here to,
Okay.
work faster. Um,
Right. I imagine
so
the caching is especially helpful if you're going to train for multiple epochs.
correct, correct. I'm going to have also batch of 16s. Well, these are numbers which can always be tweaked. But these are some, you look up any documentation of TensorFlow, these are popular numbers which show up. It kind of works for a
Okay.
lot of things. I
Right.
kind of
Yeah.
memorize these things. Okay. Okay, data set. All right. So we have the data set. We're going to split our data set into train, test, and val. At this point, we have all the vectorization ready. So we have text converted to tokens and all this stuff. Is there something that you want me to address, or can I move forward to writing my own training pipeline?
No. Yeah. I think that sounds like a good plan.
Okay, thanks. I'm gonna split the training dataset, train, validate, and test from a training. So good thing about this dataset is I can actually do something like very Pythonic way of saying I want to take, from the whole length of my dataset, I want to take 70% of the samples, which is zero point 0.7, and then I want to take, okay, I'm missing this one. I'm gonna skip this 70% and then take my next 20%. Okay. Length of data set dot star dot two. Okay. So it makes things a life bit easy.
So is this for the validation data set? This that
Yes.
20%?
This is validation 20% and test 10%.
Okay, gotcha.
Okay, I'm gonna skip the 90% of the dataset and take the last. So you have this stuff. So now I'm ready to make my own model. I'm gonna use TensorFlow's Keras API to build my sequential model. The good thing about this TensorFlow with this sequential layer is I can I can add layers to my deep learning model, just like the way you can imagine.
Yeah.
So something like this sequential. I'm gonna use. Okay, so we can think of few things here. These are test sequences. All these tokens, all this vocabulary is a large vocabulary, and a word representation is something very crucial in this. So I'm going to use something called an embedding layer, which will basically give me an concise representation of a particular word or token, let's say.
Okay, I see.
Um, okay, I'm going to use an embedding layer. Embedding layer and LSTM. LSTM, then I'll come to that later, and then bi-directional layer, I guess, and then few dense layers for my to capture more non-linearity stuff.
Okay.
Okay. Then I'm gonna say sequential.
Sorry, you said the dense layers for capturing nonlinear interactions.
Yep.
Are you using any like nonlinear activation functions,
Yes, I'm
perhaps?
going to use ReLU to capture
Okay.
this. I'm
Okay.
going to have when I say non-linearities, I mean with ReLU.
Oh,
Um,
okay. Yeah.
yeah, not just like this one, but yeah, dense layers basically help me to crunch this large size metrics to smaller dimensions, and then crunch them down, and also push all those weights back to a larger dimension layer, so that these activations help me to capture the better weights and all stuff. uh, okay. Classifier. Okay, so we have this sequential layer. I'm going to add my embedding layer on as a first layer, basically, right?
Yeah.
I'm going to use my so basically embedding layer basically converts my tokens into a representation of length I want. I'm going to push all my vocabulary size here, right? So the embedding layer takes into consideration of these things and converts that to a representation of size 32. Basically, a word was represented across this big vocabulary, and now this same token, a single number like 110, or a token of, consider a token called love, and the love has given been a number 110 by this tokenizer, and this embedding necessarily says that this 110 could be converted to a one dimensional vector of 32
Okay, gotcha.
size 32, right?
Yeah.
uh, okay. Okay, am I doing this right? Okay, embedding layer. Did I miss any brackets? No. Okay. Anyways, let's move forward. Tokenizer, I think it's with a Z. Always get confused on this. Whether it's with a Z or S. Copy it here. Git vocab 32 model down. Add. I'm going to add a bidirectional. I'm going to add an LSTM layer with some 32. Let's say 32, and then an activation function of tanH. The reason why I use tanH because this is one of the recommendations given by TensorFlow for GPU acceleration. It's kind of default that I use here. It performs well during these GPU usage. That's what I aware of. I'm going to add this bidirectional layer as well because it will help me to capture, modifiers. For example, if I say uh, I I love exponent, and if I don't have bidirectional, I if a text like I do not love exponent, so love is kind of taken as a positive word if you do not have bidirectional. But if you have bidirectional, you will run your text the other way around, and then does not comes at the end, so that this captures some sort of information about the modifiers, or some modifiers which changes the sentiment of the word, something like this. Yeah.
Right. So you're saying that the sentiment is better captured by when you have context from both the left and the
Correct.
right. Yep.
Correct. I think that's
Yeah.
that's a better way to put it. We'll capture the sentiment in
Yeah.
in the either of the directions.
And do you mind also
I'm gonna.
briefly summarizing like why an LSTM layer?
So the LSTM layer have contextual capture. They can capture context, and they also have. I mean, LSTM is basically short term memory unit, right? So basically, it says that you have this long text, and you have context in the starting of the text, and which has a meaning on something on to the end of the text. This contextual information is captured by these LSTM layers. This really works well for longer sentences where there is a context switch or a context connection from the first and the last. So they maintain some sort of a memory. They capture this context information, store it. To give an example, it says, I was so happy today. It was raining, and then I went to the movie. I saw something, and then I got sad. The whole sentiment of the sentence was actually sad. But if you do not use LSTM, you see that, oh, it was raining. I was happy. I went to movie. So all these are positive words, uh, and then the connections were somehow missing. So LSTM kind of captures this.
Okay, so you're kind of saying that it captures like the sequential nature of language, right?
Sequential nature, right? Correct.
Yeah. Does it like I guess compared against other types of like neural network blocks, does it tend to have more of a recency bias?
Um, we could say that, but we could say that, but they do perform well in terms of these contexts, and they do have this bias problem. I think the evolution of these transformers actually solves those
Yeah.
problems that LSTM poses up.
Right. Okay.
I'm going to add a bunch of dense layers. I could probably say, uh, yeah, I could probably add this, and then activation of ReLU. ReLU captures for non-linearities, as we said earlier. I'm going to add my final layer, which is basically a dense layer of size 1, and then an activation of a sigmoid. The reason sigmoid now is basically I want a probability for my final output, uh, so that so that all the numbers, I mean, the numbers can go from negative to positive, but sigmoid makes sure that everything is crunched down between 0 and 1 so that I have a
Okay.
probability.
Okay.
Um, okay,
And what does that
let's
probability represent?
probably represent that what is the probability of uh, a target label being harmful.
Okay.
Okay,
All
okay,
right.
there
Sounds
is
good.
some. Okay, no module name, TensorFlow. Okay, I'm very bad at English right now. Anyways, TensorFlow.
Okay. Yeah. There we go.
Okay, we got it. We got it. And then we're going to look at the model summary. We got text classifier. You have 32. You have 64. Since we are using bidirectional, it sums. It
Yeah.
goes 32 into 2. You have
Okay.
some stuff. You have some parameters. Uh, and I think you're all ready for setting r- training, basically. So I'm going to use
Okay.
the GPU. I could quickly check if we have the GPU. I think we are on the T4 GPU, which is good. I'm going to use the GPU to run my code, my training thing, right? Uh, Usually this, how is the syntax usually looks like? And then this opens a context for me, and then I'm going to say history, self model dot fit, correct, model dot fit. I'm going to pass my training data for an epochs. Let's say let's do it for one epoch and see how fast is it, and what is the validation loss and eval loss, basically. If things are okay, we'll move forward, or else we'll try more epochs. What do you think? Uh-huh. You can pass validation underscore data. I guess validation underscore data. Correct. Validation underscore data is my val. Did I save it as val? Okay. Val. All right. Okay. I forgot about adding a loss function, which is basically, let's do this here. Let's do this here. We didn't compile our model. We missed to compile our model. Model compilation will basically asks me for a loss. In this case, I'm going to use binary cross entropy. The reason is because this is a classification problem, and binary cross entropy kind of works well. And it's also good enough because it gives me a probability and captures this probability of yes or no kind of
Okay.
thing.
Yeah.
Uh, and then I'm going to say my optimizer is basically, I guess this works out, Adam. I could use anything, SGD, gradient descent, any other stuff, but Adam is something which is an popular format if you wanna work on with GPUs, or your faster gradient, faster way of finding of gradients and stuff.
Right.
We could we could we could go in different directions from there, but let's use Adam, right?
Okay. Yeah.
Let's compile the model and let's try it again. Looks like it is starting to process information.
Oh, great. Yeah.
Okay,
Looks like it's training.
looks like it's training, and this is what it gives me, 12 minutes, but it's fine. Um,
So while we wait for this to train, maybe we could talk a
Yeah.
little bit about like what are some things that you would look for while the model is training. And you don't have to implement this, but I'd just love to hear your thoughts on this.
Okay, I would probably look into the way the loss drops for every epochs, correct, and
Hmm.
also look at the validation loss, uh, and just to see if my training loss and validation loss they converging over time on every
Hmm.
epoch. If they basically do not converge, that means my training is not happening the way I wanted, or it's not the right way of training. I mean, if they converge so fast, it's also an indication of overfitting all these things. And if it does not converge, it kind of underfitting kind of a signal that I would look for.
Okay.
Depending upon that, I would choose, okay, what do I have to do in terms of overfitting? Should I have to look into my model, change some stuff, maybe add a dropout layer, maybe use different, not an LSTM layer, maybe use some sort of a max pooling convolution neural network stuff
Hmm.
to minimize these things, or use some sort of regularization, or I should go back to the data and make some more pre-processing, probably look into my tokenization stuff because I've used a pre-trained models,
Yeah.
which could
Uh-huh.
may not best fit for our use case, but let's see. um yeah, that those are things I would have it in my mind when these things go on.
Gotcha. And you mentioned for checking for overfitting or underfitting, which is a great thing to look for, by the way. You mentioned that
Mhm.
you would identify it's overfitting when it's converging too fast. What do you mean exactly by too fast?
I mean, one epoch. Yeah. So basically, when I say converging too fast, right, the loss drops quite drastically in a second epoch, and then it doesn't move. Correct. That for me is a fast convergence.
So I'm curious then if there's some way that you could determine overfitting by looking at not just the training loss, but looking at other numbers as well.
Yep. I could also use I have already a test data set which I've kept aside. I can basically I can run this model on the test data set and see how well it is performing. If the basically if my metrics are pretty bad and low, then it's a sign of overfitting as well because I'm not doing well on my training on my testing.
What about the validation loss? I know we have a validation data set, right? But we haven't looked at that at all. Can you maybe look at whether or not the model is overfitting by comparing to training and validation loss?
We could also do that. I mean, validation loss is something that has to be coming down as we see
Hmm.
on more epochs.
Yeah.
That's one indication to look as well. And validation loss should not go bumpy. That's also one indication. Yeah, that those are things I can think of.
Yeah, maybe if like the training loss is much lower than the validation loss,
Validation
then
loss.
that's
Yeah. Yes. Exactly.
yeah, it's
Exactly.
probably an indication of overfitting, right? Yeah,
Yep.
okay, very cool. Um yeah, okay. So another thing I was curious about then is how would you evaluate this model once you finish training it?
Um, So I would probably run this on my test set and see how my model performs
Hmm.
to get some numbers on my test set. Basically, I could look for precision metrics like precision recall, and also accuracy would do well in this case, I
Hmm.
guess. But since of imbalancing, we would rely on precision recall. Um, it could give me an idea about what how well is my model doing on true positive, capturing true positives and false positives, all this
Hmm.
stuff. And then I can also run some sample texts that come up on our mind about having a negative word in it, whether it my model actually classifies it as not harmful,
Hmm.
which is what I would look for.
Okay, great. Yeah, I like that you also mentioned like precision and recall in addition to accuracy because most of the times data sets are imbalanced. That makes a lot of sense.
Yeah, yeah.
Um,
We
yeah,
could
so
uh, we could sketch up the evaluation meanwhile it starts
yeah,
running when I
yeah,
finish
let's
that,
see
so that
some evaluation code. Yeah.
yeah, 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 it's just to save some time and keep things going on. TensorFlow dot. I'm gonna use the TensorFlow as well. I'm gonna take some metrics from the TensorFlow. Import precision, I guess. Precision, right spelling. Okay. Recall and then accuracy. Okay. Let's initialize these models. Um, I think they're basically classes which can be instantiated like this. Okay, I didn't write precision, and then I have accuracy. So I would, since I have this TensorFlow data set, it basically gives me every batch, right?
Mhm.
In test dot, I can I can create this as a NumPy iterator. I guess there is an inbuilt property, inbuilt member function, iterator, inbuilt method basically, like this, I guess, iterator. Uh-huh. So basically, it gives me a batch of data. I guess it were a batch size was 16. I remember, and then we will have x underscore true and y underscore true are basically my uh, text test information. And now I want to make a prediction. Basically, okay, what is this? Uh, x underscore true and then y underscore true um, batch, and then I'm going to make a prediction saying that y hat equal to model dot predict. I don't have to tokenize it again because my test set is already tokenized. So I just have to say model dot predict of x true. Y hat is basically an estimation of my predict, and
Mhm.
then y underscore, yeah, and then I'm gonna say my precision has something like this. Classes have something like update underscore state, which basically updates the state of the precision metric for every run, every
Mhm.
batch, like passing this one y underscore true comma y underscore hat. Yeah, y underscore. You could do the same stuff for our recall and accuracy, and then in the end we could probably print precision recall accuracy. Okay.
Okay, great. Yeah, this looks like
Okay.
some great evaluation code.
Sure.
Okay, so I think in the interest of time, we don't necessarily have to wait for this model to finish training, but I'd love to like
Mhm.
discuss a little bit more like some of the things you would continue to do after the model has finished training. So let's say, for example, that you've noticed that maybe the model is much better at capturing positive sentiment than negative sentiment. What do you think you would do in that case?
Uh, so that comes from the data set that you have trained. Your data
Hmm.
set has more of positive samples. That's most likely that your algorithm gonna learn more of positive and less of negative.
Hmm.
Uh, that's one area that I would solve. I'll probably make a balanced data, unbalanced data set to a balanced data set, and make sure that you have all you have. Make sure that you have the negative and positive the same size, so that
Yeah.
the algorithm learns them equally.
Hmm.
Uh, yeah, that would be one, and also I would probably add. Yeah, I think that's one. That's only that, I
Okay.
guess.
Great. Yeah, I think that that makes a lot of sense. That does tend to be like the predominant problem of like uneven class accuracy like that, you know?
Yeah, yeah,
Um,
yeah.
so I'm also curious, what about, let's say that you've noticed that the model tends to pay more attention to sentiment words that are near the end of your sequence. How do you think you would try to solve that?
I see. I can't really think of an answer for that, but probably I would tokenize it much better and
Mhm,
also add weight. I would also add some, what do you say, what is this called? Placeholders or some
mhm,
labels,
mhm,
which basically identify them on identify these end words and probably give
mhm,
them a less weight
mhm.
in terms of tokenization, or even in the creation of embedding layer. I would probably play with it.
Ah, okay, I see. I'm curious about what you mentioned earlier on in the interview. Then we talked a little bit about like the choice of LSTM, for example, and you also mentioned
Mhm.
transformers as a possible choice. Do you think if you switched the type of model, it would make a difference on that particular problem?
It it could, because for example, the BERT, right,
Mhm,
bidirectional encoding, correct. It has this encoding and a decoding component.
mhm,
Um, it might make sense in terms of having an embedding layer, which is kind of the crux of these two components, I guess.
mhm,
Not really sure how it works, but I would say advanced models could probably handle it better. And I
mhm.
don't really know the technicality of why and what.
Yeah, okay. Yeah, because it might make sense because BERT is like an encoder only model, right? So it has this attention
Mhm.
mechanism that intakes the entire sequence at once.
Yeah,
Versus with the LSTM, it's sequential, and so there's more signal placed on tokens that are more recent, right? So it kind of makes sense then
I
that
see.
maybe the classification would be more influenced by tokens near the end of the sequence
I
versus
see. I see.
where it might be a little bit more robust to that. But of course, that's an empirical question and one that you'd kind of have to test out for yourself. So
Yeah, yeah,
yeah, okay,
yeah.
Jay, thank you so much for answering this question for us today. I thought that was really fantastic. I'd love to hear now a little bit of analysis from you about like what do you think went well about this, and what do you think you might change.
Uh, I would change this training code first of all. It's super slow. Um,
That's okay. I think that's
yeah,
also a function of computational resources.
yeah, exactly.
Yeah.
I think problem definition wise and the way well, I didn't present alternative solutions. I've only
Hmm.
presented a single solution,
Yeah. Hmm.
which is kind of bad, I guess. Uh, I think the good thing should have been like I should have got some couple of probable candidates for
Hmm.
solving this problem, and then made a pros and cons list for each of them, and
Mm.
then come up with a winner model saying that, hey, this could work because of these reasons.
Gotcha.
I
Okay.
think this was missing.
Mhm.
I should have made more emphasis on that.
Well, I think on the flip side, though, I really like that you did a good job of like justifying most of the design decisions that you made. You know, you
Mhm.
like justified why you would use a BERT tokenizer because of like the sub word tokenization, and you also
Mhm.
mentioned like why you chose a particular activation function. So I thought that that was really helpful because at the end of the day, it can also be kind of difficult to present like the pros and cons of all possible alternatives. So
I see.
like trying to find that happy medium in between is really helpful.
Okay.
Yeah.
Yeah.
Mhm. Yeah. Um, yeah. So yeah, that part I really liked. I like that you asked a lot of really detailed, clarifying questions too, and not just about like the machine learning part itself, but also about its use cases for like downstream. And as you
Yeah.
mentioned a little bit yourself, that's really helpful for designing like your interfaces and also figuring out what kind of evaluations or monitoring systems that you might need later
Mhm.
on. And I like that
Mhm.
you inspected the data first to check the quality. That's always important in like real life machine learning scenarios. Um,
I see.
yeah, and also I like that you talked a little bit about possible ways to fix like underfitting or overfitting if you do happen to
Mhm.
see that in your evaluation metrics. Yeah,
Yeah.
and as we also covered a little bit, you created this validation data set, but then it was kind of
Mhm.
underutilized. So I would have been curious about like, okay, if you have this validation data set, what are other things you could use it for? And one thing we sort of touched upon is like checking for overfitting or underfitting, and you can
Yeah.
also use it to do like hyperparameter searches, right?
Correct. Correct.
Yeah,
Correct.
yeah,
Exactly. Yeah. We.
yeah,
I think I didn't touch the part of hyperparameter tuning at all.
yeah,
There is this whole concept of grid search and random search kind of a thing, where you know you can
yeah.
work on in that direction too. I think that's one missing point as well. Thanks for mentioning it.
Yeah, and that's okay because it's like it's hard to implement all of that in addition to everything you've already implemented here.
Hmm.
It's
Hmm.
more just like a helpful point that you can totally bring up. And
I
then
see.
one thing I'm curious about is are there any other so accuracy, precision, and recall as you've computed here? They're all somewhat like types of measures of accuracy. Are there any other axes that you would want to evaluate this model on?
Um, no, not really. I think of.
Yeah, so something I'm curious about might be like calibration, for example, because
I
a
see.
lot of neural network models may be underconfident or overconfident in their predictions, right? So
Okay.
if you have a well calibrated model, you can sort of assess the level of certainty of the prediction. And that could help you in like a real world scenario where you want to deploy this
I
model.
see. Are you also referring to SHAP values, kind of thing?
Yeah, you can use
Like
that as well.
interpretability. Yeah, SHAP. Yeah, yeah, yeah.
That I
Okay,
guess is
okay.
more for like interpretability and less so uncertainty,
Uh,
but they're definitely like related to each other, you
I
know?
see. Yeah, 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 yeah.
Yeah.
Somehow got it, got it.
Yeah. But yeah, so I'm sure that's something that we could have talked about too. Like if you wanted to extensively compare like different models, like in general,
Hmm.
neural networks are a little bit less interpretable, even though they're also more powerful than a lot of the interpretable models. So that's definitely an interesting aspect as well. Okay, so thank you so much, Jay. I think we have really learned a lot from you, and this was like such a well implemented interview overall. So thank you for being
Thank
here,
you.
and
Thank
thanks
you.
to all of our viewers for watching today. Good luck on any upcoming interviews that you might have. Okay, bye everyone.